We're coming now to our ninth speaker, Yousef Alqaryoti, and his presentation is on breaking the wall of prefabricated houses.
Major disasters leave a long, deeply stressful process of rebuilding homes. Following these disasters, people urgently need for suitable houses to live, heal, and recover. Prefabricated modular construction has been identified as an effective method for low-cost and rapid post-disaster reconstruction. However, manufacture of these systems require specialist expertise and facilities. So there is a high risk of production delays in emergency situations. We have developed a new type of a prefabricated house using digital fabrication technology by subdividing the house envelope into components easy to cut by numerically controlled machines and easy to assemble by non-skilled people. This house can solve the current limitations of prefabricated systems for community reconstruction. The house is a modular assembly of timber arches. Each arch is a folded sandwich structure and can be folded from a flat state to an arch state. So, like each segment of this arch can be subdivided into timber plates. These plates are connected together by traditional press-fit joints. The construction of the house is following these, so it's come in back, and then you can assemble the components and fold it, and then put the arches into place. The house prototype has demonstrated the efficacy of the fabrication. Takes 3 days fabrication and 1 day assembly at a cost of $170 per meter square, which if we compare it to the current, like the lowest price product in the market, in Australian market, it's half the price of this product. The house will be a solution to people who are suffering from extreme events, allowing them to have affordable, sustainable, and suitable housing. Thank you.
Thank you, Yousef. I see a question over to the left, in the center here. Over there first, please.
Thank you. Unfortunately, these days, people require that type of housing for an extended period of time. Have you given any thought? I can see you've thought about the cost at the start, but have you given any thought to how you would measure the durability?
Exactly. So actually, in my research, currently I'm focusing on to figure out how we can extend the lifespan of the structure. So this is mainly depends on how, let's say, the engineering details of the waterproofing and the fire safety.
Could I just ask how, you said this is for reconstruction when there's disaster. How transportable is this? How many can you how much can you pack into one container to get wherever it needs to get to in the world, and how quickly could that be done?
Yes. So actually, this is depend on the size of the container. So as we see, we divide the house into components, into plates, like small components. So you can ship all these parts, because it come in package, to the remote locations or to anywhere. And then at the site, you can open the back and start assembling the segments as our Lego works.
And we got 2 questions there in the back. Thank you. Maybe start right at the back and then the one in front.
Thank you. You said that it took a day to manufacture,
3 days.
3 days to manufacture and 1 day to assemble. If I'm understanding what you're saying correctly, that suggests that you wouldn't be able to supply this shelter for at least 4 days for someone who's been exposed to a natural disaster or something like that. How does that compare with the alternatives of providing a tent or something like that, which doesn't really need much more than putting up.
So now we are thinking about, is like a tent a suitable place for the people to live in? So like this is the main question. And the other thing, it's like the lifespan of the tent. Usually tents is provided for up to 1 month or maybe 3 months. But after that, what's your solution to provide the people with, let's say, with permanent housing?
Good. One final quick question.
Perhaps following on from the first question, how structurally robust and sound are these houses against things like high winds, earthquake aftershocks, these sorts of things?
So actually the house structural system designed to sustain wind loading. And currently we are like developing more methods to test the arch under different loadings, such as like lateral loads, earthquake, or other types of loading.
Thank you, and thank you, Yousef, again.